Hi, I consider this problem to be one of the most deceptively difficult problems in all of physics. And it gets to the heart of how to use Newton's second and third laws in solving for the acceleration of a system. So the problem is, two boxes are sitting on level ground that has zero friction. And box A has a mass of 5 kilograms. Box B has a mass, I wrote 15 kilograms initially, but its mass is actually 10 kilograms in the example that I want to do. And I am pushing the two boxes with a force of 15 newtons. So what is the acceleration of the boxes, and what is the force between the boxes going to be? Now, the most tempting answer, and the answer that I see most students wanting to just jump to immediately, is to say there's a 15 Newton force pushing on box B. And that is 100% incorrect. So if we want to figure out what's going on, there are two approaches we can take to solving for this scenario. One approach is we could always try to find the acceleration of the system as a whole if we can identify the total inertia of our system and we can identify the total outside force acting on our system. So, my system, I've drawn a dashed box exactly around the edges of my two boxes. So, this won't allow me to figure out the force between the boxes, because that is an internal force. And from Newton's third law, A pushing B is canceled by B pushing A inside our same object. Now, we have a 15 Newton force pushing from the outside to the right. So in my free body diagram, in the positive x direction, I have a force of 15 newtons. Now this object has a weight pulling straight down because of Earth. So I'd have the weight going down, it's sitting on a table, so there's a normal force, and since the touch happens perpendicular, the normal force is going to be up and down, and because the boxes are above the table pushes the boxes up. So my normal force is up, and those are my two forces in the y direction, and those two forces have the same magnitude. So there's going to be no acceleration happening in the y direction. There is no friction here. I said this is a totally smooth table, and we can worry about what happens with friction as we start adding in more detail to our reality. So in the simplest case then, our acceleration is going to be the sum of our outside force, 15 newtons in the i-hat direction, divided by the mass of our system. If A is 5 kilograms and B is 10 kilograms, our system has a total of 15 kilograms. So 15 newtons divided by 15 kilograms means I have an acceleration of 1.0 meters per second squared in the x direction. So, how can we figure out the force between the boxes then? Well, what we could do is, instead of thinking about the system as one big system, we could think about it as two smaller systems. Box A is going to be my first system. So imagine I do the same thing drawing this dashed line, but now instead of including B, I'm keeping B separate from A. So the 15 Newton force is still pushing on the side of box A. There still is a weight, but now it's just the weight of box A, and a normal force that's just the normal force from the table touching box A. Well, the net result in my y direction is still we get cancellation. So if I just look at my x direction, I'd have that 15 Newton force pushing forward, but then on this other surface, A is touching box B. So my normal force is perpendicular to my surface is vertical, so my normal force is going to be horizontal. And since B is touching A, B is pushing A to the left. So I'd have 15 newtons to the right minus the force of A pushing on B. And if I write down Newton's second law, the second law says the acceleration is the sum of my forces, 15 newtons, minus the force between the boxes, divided by the mass of A. Now, technically we know our acceleration, we know the mass of A, we could solve this and find the force between the boxes. But let's assume for a minute that we didn't calculate acceleration first. Well, we would have two unknowns. We have this unknown force and this unknown acceleration. So we need another object to give us another equation. And if we have two equations and two unknowns, as long as we have the same unknowns, we can solve for both. So if I look at box B has its weight, box B has its normal force, and again, we're not worried about the y direction because we don't need to make use of that normal force from the table anywhere. So we only have to worry about the x direction. And in the x direction, the 15 Newton force isn't touching box B, it's touching box A. Instead, box A is what's touching box B. So the force is still that normal force. We're looking at that normal force though as it acts on B. So if we said B pushes A to the left, we say A pushes B to the right. So our force is the normal force between A and B, that single interaction, but our force picture is now showing it pointed to the right. So our acceleration is just the force between the boxes, the force of A, B, divided by the mass of B. We'll talk about why 15 newtons shows up in here in just a moment. So our acceleration is the force between the boxes divided by the mass of box B. Now, this acceleration and that acceleration have to be the exact same acceleration. And the reason for it is, one, we don't allow ghost boxes. If A were to have an acceleration greater than the acceleration of B, A would have to be passing through B. They couldn't be changing their motion the same, so at some point A would have to be on the other side of B. And ghost boxes don't work. Now B can't have an acceleration greater than A, because if B were to accelerate more than A, B would separate from A, and if they separate, they're not touching, and if they're not touching, there's no force, and if there's no force, there's no acceleration, which means A would catch up to B. So one thing that's possible that could happen is the boxes could be doing this slam into one, and keep doing that, but that's not what's happening. The two remain in contact as that force is accelerating them to the right. So if those two accelerations are the same, I can solve this equation by setting my two accelerations equal to each other. 15 newtons minus the force between the boxes divided by the mass of box A is the force between the boxes divided by the mass of box B. So, to solve for the force between the boxes, I'm going to get rid of this denominator. Multiplying both sides by the mass of A, 15 newtons minus the mutual force is the mass of A divided by the mass of B times the mutual force. So then I add that mutual force to the other side, and that tells me 15 newtons is the mutual force plus the mass of A over the mass of B times my mutual force, or my mutual force times 1 plus the mass of A over the mass of B is 15 newtons. So the last step, I divide by that distribution that I just did. So the force between the boxes is 15 newtons divided by 1 plus the mass of A over the mass of B. A has a mass of 5 kilograms, B has a mass of 10 kilograms. 5 kilograms over 10 kilograms gives me 1/2. 1 plus 1/2 is 1.5, and 15 newtons divided by 1.5 is 10 newtons. So the force between the boxes has to be 10 newtons. Now we get to check our work. Let's see if we get 1 meter per second of acceleration using Newton's second law. Well, I have 10 newtons divided by 10 kilograms. 10 times 10 gives me 1 newton per kilogram, which is 1 meter per second squared. Now, triple checking it with box A, my acceleration should be 15 newtons minus the force between the boxes. So I have 15 newtons minus 10 newtons, which gives me 5 newtons divided by 5 kilograms, which yet again is 1 meter per second squared. So, quick check. If you try to calculate acceleration using 2 different methods and you get 2 different accelerations, there's a problem. Stop. Check what's going on. Come back to it. So, use the checks that math gives you to try and make sure that you're staying on track. Thanks for watching.